32, there should be a space there, .x.cab. Now that's something which is operating system dependent. So WinNT, Win2000 called it extract32, whereas 98 called it extract. So typically you'll see scripts that actually called both, saying, all right, we're gonna first call extract. If that doesn't work, well, I'll call extract32. And so that basically means that you end up with a like a script that automatically has an error that already shows on the screen even before your production is running. Now, I mentioned there was a second phase of self-extracting, and this is based off Windows XP. And I won't get into the serious technical details on it, but if you're interested, I can certainly discuss it. But one of the things that happens is that when you try running a batch file in XP, essentially if it finds gobbledygook, it will seek, once it finds a 0 character, it will actually seek to a certain character sequence, trying to run the rest of the batch file. So it has this error sort of coping mechanism, you could say, if it encounters a bad batch file. So the way that this typically works is that you create a batch file, you put the cab file in it, and then you put an end-of-line sequence into it, and then you put your script. So then you can actually extract your batch file. And that is very OS specific. Now, there's a very good tool by Mumak, another Finnish fellow, that is hosted on 24to4.net, the idea that you take 20 kilobytes and you shrink them down to 4 kilobytes. However, our production, which we started with, which was 11, only goes down to 4,906 bytes. Remember, our goal is to get underneath 4,096. So we're getting closer. Disadvantages. To support OS compatibility, you have to make multiple calls. And remember when I said you can do this nifty thing with the error coping mechanism of Windows XP? Well, guess what? You end up with this really ugly line right up there when that cab file runs. It's good compression, but it isn't context sensitive. So it interprets everything that you're doing the same way. And it basically sees your program not as a program with data and code and routines, but it sees it as a big stream of bytes and bits. And to really get beyond this, this was the de facto standard for probably the last, I don't know, about a year and a half, 2 years ago was the de facto standard. But to go beyond that is you need to get into the code generation itself. So there are tools that are replacing the linker inside executable generation. And that actually means that it can look at and understand your code and make a better type of compression, context-sensitive compression, specifically for your program. I also mentioned for any of the Linux gurus that I was going to try to talk Linux, so please forgive me if I butcher the OS. I really love it. I used to admin on AIX many, many years ago. So cab dropping for Linux. Similar approach. You use gzip. The intro runs a shell script that extracts it, and I have an example here, which basically says, take the tail end, copy it out, make it executable, run it, delete it, and exit. So it's a single line, and the really nifty thing about this is that you don't end up with any of the sort of heart-stopping gobbledygook that occurs in the Windows platform. And you can read more about the cab dropping technique. So getting into the new linkers, the de facto standard in the 4 kilobyte community at this point in time is to use a tool in the Windows 32 platform called Crinkler. And that's sort of a play on words based on linker. And it was put out by the Blueberries and TBC, sorry, Mentor and Blueberry and
those guys.
Those guys. Thank you. Thank you. I'm falling all over my Canadian accent. Thank you. And you can find out more information on Crinkler.net. I should also mention there are some alternatives that are up in the wings. There is a a link here for A-Link, which is alternative linker. And it looks like if somebody was, fairly entrepreneurial about what they wanted to do, they could also find ways of using that to reduce their size. But at this point, we break the 4 kilobyte barrier. We end up down to 2,457 bytes. Now, if that was all there was to it, we wouldn't have the productions that looked as fantastic as they are. So to show you, again, we mentioned that we're going to do the out-of-the-box techniques. I haven't altered the code in any way. I haven't changed the way it runs. It's still the same executable image. I've just changed the way it's represented. Estech is going to talk about actually changing some of the inside the box in order to drive it even further.
All right, well, that part of the talk was supposed to be 15 minutes. It's actually been 30 minutes, so I got to really rush on this next part. All right, basically, the compressors are limited. We were able to go from 11K down to 2.5K using the Crinkler tool, which is impressive, but it only leaves 1.5K for music and graphics. It's not enough space to make something impressive. So if we really want to get down and make a good production, we have to trim that fat and get our code and our data down as small as possible so we can make a nice use of the rest of the space. So value size over maintainability and correctness. Be ruthless. There's no reason to be nice and, like he said, check for errors. If an error happens, let it happen. Who cares? Your program crashes, you get a nice dialog box. So the first thing I'm going to do to make the program smaller is remove the C standard library. Every C program you compile gets this library in by default. It has 2 parts. It has a DLL that has a bunch of standard functions, printf, malloc, stuff like that. It also has a part that is the startup code. So when the operating system launches your application, it doesn't launch directly into your function. Instead, it calls this other function, winMain CRT startup, which does some initialization junk, calls static constructors if you have static objects, and then it launches winMain. So the first thing we can do is simply rename winMain to winMain CRT startup. That way the linker says, oh, this is the real entry point, not the one in the standard library. Also, we can't call any standard library functions if we don't have the standard library, obviously. So in the Nihi tutorial, she calls malloc on line, no, memset on line 215. So we have to replace that with some alternative code. Some compiler features also call into the standard library. So we can't, for example, do stack checking, to make sure we haven't done a buffer overflow. So some stuff like that has to go away. If we do all these things and we remove the standard library from the linker options, we end up with a 473 byte reduction. So that takes us down to 2,166 bytes. So it's a small savings, but when you consider that it's 400 bytes, it's almost 10% of the entire production right there. So it's very good. If you don't have a standard library, there's some tricks you have to do in order to code in C. You can't use library features like new and delete. Sometimes, if you have like a big structure and you set it to 0, the compiler will secretly call memset in order to do that. So you have to be very careful. Typically, the way you would handle that is by using static memory. I'll talk more about why that's good later. Also, big one is floating point integer conversion uses a routine in the standard library. So if you cast a float to an int, you have an explosion. So the way to handle that is you get a 4K math library, which contains inline versions of all the math.h functions, so you can still use those. And it also provides an F2L function, so you can do your floating point integer conversions. We include one of these in our package that goes with this speech. It'll be on the In4K site. Actually, I stole it from a guy named Chaos, and you can Google for it on the web. It's right there. The next thing I'm going to do is remove windowed mode. Now, in the Nihi tutorial, he actually has a mode where it can be run as a window or as full screen. Well, it's a demo. It runs full screen. There's no need for that, so I go ahead and remove that. It has a switch that only renders when it has focus. Well, we'll just always render because it's a demo, and no one should ever be switching away from it. Until it exits, of course. Unless it sucks. But then you can press escape. Also, he has some code that says, no, don't start the screensaver. Well, I don't think there's any 4Ks longer than 2 minutes or maybe 5 minutes at the most, so screensavers aren't a big issue. He has some elaborate keyboard code. Well, all we need to do is check for escape key, so we can kill that. OpenGL state setup. He calls a bunch of functions that are purely redundant. Get rid of those. So just by removing obvious sort of stuff, we get a 520 byte reduction. So that takes us down to 1.6K. The next one is kind of controversial. We've been mentioning this over and over again. Remove error correction. So if you try to allocate a window and Microsoft Windows returns null, you're not going to give you a window. Normally you'd have a nice error box that says, oh, we're out of memory or something. But hey, if you try to use that null pointer, you'll just get this, your program has stopped working. Your program has caused, Microsoft will report the problem and, just some stupid generic error box because your program has done a seg fault. But that's okay. The user clicks close program and figures, oh, that demo didn't work.
That dialog box, by the way, is from Vista. So if it doesn't look familiar, that's Windows 98 was the blue screen, right? So then it was replaced with some other dialog boxes in XP. Now, of course, you've got Vista. And actually, one of the other things I'll mention is that as we go on, you can see more and more the compatibility line changes. And that's why a good 4 kilobyte intro developer will release a 64 kilobyte version of their production called compatibility version, as opposed to 4K. So they show that they can do it in 4K, and if it happens to be 5 years later, then you can run the compatibility version.
The other thing, too, is cleanup code. Now, if your program can crash and not bring down the operating system, you can leak memory and not bring down the operating system, too. It makes sense, right? So just leak everything. OpenGL context, window handles, memory, anything and everything you allocate. There's no reason to free it. Let the operating system do it. It'll clean up your mess and save some space. So we have a 406 byte reduction from removing the error handling, and we're running without protection, but I mean, hey, who cares? It works. So you can see the size is getting down by just removing stuff. Now we have to get into the realm of creative use of the Win32 APIs. Now this is probably going to be weird, but it works. For example, normally you register a window class and then use that window class to build your window. Now Windows has some built-in classes for things like buttons, edit text boxes, static controls. So we just use one of those as our window class instead. That saves a function call. Normally you call show window to show your window. Well, just use the WIS visible flag. Window messages, normally you'd like to loop and process messages like resize the window or whatever, but all we're using the window for is to output stuff to screen. So there's no reason to process mouse input or keyboard input, just simply don't even include the code. Also, because we're using a compressor, a 0 byte is typically smaller than a byte that has some random number in it. So anytime we can use a 0 as a structure field or a parameter value, that's a savings of bytes. So for example, instead of when you call create window saying, I want this window to be 800 by 600, use the WIS maximize flag and it'll just be full screen. Another thing, some structure fields you can leave blank, like when you go to create your OpenGL context, it wants a field that has the size of the structure for error checking or whatever. That one you can leave blank and it doesn't care, so leave it blank, save some space. Another thing you can do is store your stuff in static memory. In C, there's 3 places you can put stuff. You can put it on the stack, which is sort of the default location for new variables. So if you just create a random variable, odds are it's going to go on the stack inside your function. The other place you can put it is on the heap. So if you create your data using new or malloc, it's going to go on a place called the heap. Now those 2 places aren't that good because if it's on the stack, the C compiler has to allocate it. If it's on the heap, you have to call a function to allocate it. There's another place called the static data area. This is where variables that are declared with the static keyword go. It's also variables that are global variables go. And this is great because it's actually allocated by the operating system when it loads your program. So there's absolutely no code involved. So if you can get away with it, declare all your variables with the static keyword. It makes your code smaller. Well, experiment. Some variables helps and some variables it harms. But for like big data structures, always put those in static memory. All those techniques, using the static window class and all that other stuff, gets us about 235 byte reduction. So now we're down to 1,005 bytes from the 2.5K we started off with before we started trimming the fat. You can do better. This is for the insane and the people who don't like sleeping at night. You can use assembly language. Now, the thing to realize is the compressed size is all that matters. The size of the code and the speed of the code don't really matter. Normally, a C compiler is way smarter than a human.